Welcome colleagues, this is Learn Extra Teacher Talk, and today we're focusing on mathematical literacy. Welcome to the show. My name is John. We're going to be having a look at the teaching of probability today. Before we get into that and sharing some ideas about how we approach this interesting topic that some people find a little bit challenging, well, let's have a look at what the Learn Extra schedule is. It hasn't changed much, but there is some important information that I want to give you. So remember that for your learners, we have a live presentation at 4 o'clock, directly after this, for the grade 10s. Then at 5 o'clock, there's the grade 11s, and at 6 o'clock, there's the grade 12s. Now, those are what happen on the weekdays, but on the weekends, we have a special broadcast that is going to be particularly important as we head for the midterm or the mid-year exams, because it's about revision. And so we're having some revision sessions in preparation for the exams coming up soon. Take a look at the schedule. We have mathematics at 9 o'clock. At 10:30 is physical sciences. At life sciences as at 12. Then mathematical literacy is at 1:30. And there will be accounting and geography starting from the beginning of June. So from the first weekend of June, the 2nd of June, that's where we're going to be having those accounting and geography sessions coming in. And we hope you'll encourage your learners to join us for those. Then on Sunday, similar time slots for the first 4, but then we're going to have a repeat of the weekday live session in the afternoon from 3 o'clock until 7 o'clock in the evening. So it's maths, physical science, life sciences at exactly the same time slot. These are 1.5-hour revision sessions. And so learners can make sure that they're adequately prepared for work that they've done earlier in the year and make sure they're keeping up to date and well prepared for the June exam. Now, all of these are possible and we want to interact with our learners. So here, how we're going to do that. These are the contact details. Our phone number, 086 1058 262. Our email address is helpdesk@learnextra.co.za. And then the very popular Facebook page, I'll just go to that in a second. It's a Learn Extra for facebook.com/Learn Extra. And our Teacher Talk Facebook page, that's also something where we'd encourage you to share your ideas, put a post up, ask your questions, and we'll get to that. Let's have a quick look at those social media platforms. The first one, the Teacher Talk page, there we are. Then the learners Learn Extra page, and you'll see that there are a significant number of learners that have liked us, and if they've missed a show, they can go on to the YouTube page, take a look at the videos that are there and get those downloaded as well. So that's the Learn Extra program. What are we going to be doing in this session? Let's just have a quick look at the little topics that we've set up. First of all, we're going to say, why do we teach probability? We're going to take a look at the teaching approach or suggested teaching approach of probability, ideas for assessment, having a look at what the CAPS document has to say about assessment of probability as a topic in general, and then have a look at a few resources that might be helpful in your teaching of probability, some ideas to extend your learners to make sure that they've got the concepts all firmly bedded down and they're very familiar with interacting with the world of probability. Well, we're going to go to a short break before we get into this discussion, so don't go away. I'll be back right after this. Welcome back, colleagues. This is Learn Extra Teacher Talk. My name is John, and today we're looking at the teaching of probability. Now, I know that some people, when they hear the word probability, they go into shakes because it's not a section that has traditionally been taught. And there is some fairly advanced mathematics behind probability, but that's not what we're dealing with in mathematical literacy. It's the concept of probability, the everyday idea of probability. And so we're going to ask the questions, well, why do we teach probability? Well, because it's around us all the time. And I want to just give you a few examples that remember that mathematical literacy is about what's happening in everyday life. And what learners are going to find when they leave school, they're going to be exposed to the media, and they're going to see different things that are expressed as probabilities in different ways. They might not be familiar with that. People that are not mathematically literate don't know how to interpret this a number or these figures that are thrown about in the media. They're not exactly too sure. So what we need to recognize is, because it's used so frequently, and we'll show some examples of that, it's really important to get an idea of what's happening. So what I would suggest is, why do we teach probability? The first thing is because it's everywhere. It's in the media, it's used in advertising, but then I believe there's another class of issues that relate to probability and that I believe are really important as far as mathematical literacy ideas. One of the key focuses in mathematical literacy is the ability to communicate about numbers and to explore an issue. And so there are two issues where probability falls into very, very, very nicely. And so I want to raise those two issues. And the one issue is the issue of gambling. This is a discussion that I believe should be something that we prepare our learners, and particularly in grade 12, where many learners are heading towards the age of 18, where they can begin to gamble. And we need to have a discussion about the social issues that relate to gambling, the responsibility that people have, the dangers and the problems that are associated with gambling. These are all issues that require some discussion. So there are issues, and the first one, as I've mentioned, is gambling. The second issue is related to health. And although in many schools and in many situations, learners don't want to talk about health, and specifically the issue of HIV and AIDS, I believe that we do need to engage learners on this very important topic. The testing that takes place, voluntary testing and counseling, is an issue that we need to engage our learners with. And if we're talking about testing, we need for them to be able to interpret their results. We're going to have something more to say about this particular issue a little later on, when we have a look at some resources that you might want to use in your classroom. Bear in mind that when we're dealing with testing, the idea that something could be a false positive or a false negative is something that learners need to be very aware of. There's recently been a case in the media where people are upset because they were originally told that they were HIV positive, and it's come out a little while later that they're actually HIV negative. There's been a false positive. They didn't follow it up, and therefore they've gone through a whole lot of emotional trauma and angst in terms of what are they going to do, not sure of their situation, and so they're now saying the test was wrong. Well, that can happen. We need to understand that is a possibility. And then in terms of science, I believe that the science in media also deals with probability. Not only advertising, but we have the science of media, reporting on science, and specifically we have things called meteorologists and weather forecasts. Now, I know that there are some people that just listen to the radio or watch the news simply to get the weather forecast. How do we interpret this weather forecast when they say there's a 60% chance of rain? Well, this is a scientifically worked out figure, and we need to understand what it means. And so for learners to be able to interact with this download of numbers expressed in a particular way, they need to understand the concept of probability. And so what we're going to do is say there is enough evidence when we look at the broad section of things, the media, we look at ideas around issues, we also look at science, and we can also even add economics. Learners are going to be faced with the idea of insurance, and we do some exposure to insurance in financial aspects of mathematical literacy, but in terms of savings and insurance and risk, this is another area that learners need to be comfortable with. They need to have a good understanding of what risk is all about. Why is it more expensive to take out insurance when you're between 18 and 25 than between 45 and 50? And understand the idea of risk that actuaries work out in terms of the probability of people having particular functions or possibility of having an accident. So there are some contexts in which to place this motivation for dealing with probability. It's not something to be scared of. It's something to embrace. It's something that's part of the real world. And if our learners are going to be citizens of the 21st century, they need to have an idea of what this word probability means. So what's our teaching approach? Let's have a look at what the curriculum talks about when it deals with probability. From the CAPS document, we recognize that there are the importance of understanding expressions of probability, the idea of predictions, representing possible outcomes, and evaluating expressions. Now, for grade 10, this is for grade 10, this is for grade 11, and this is for grade 12. You can see that there's a progression. And we're simply in grade 10 wanting to introduce learners to the idea of probability. What's a probability expression? And where do we find it? And there are two contexts that are suggested in the CAPS document. Not that our context should only be limited to those, but the two contexts are about games that deal with coins and dice, and then weather and predictions. Now, if we look at expressions of probability, we need to recognize very simply what expressions of probability are. We can express the idea, expressions of probability. The way that I've seen probability expressed and explained really well is in terms of getting a number line and setting it up to say at the one end, if we understand that at this end there is absolutely no chance of an event taking place, and at this side there is going to be, it's absolutely certain. If we have this continuum from no chance to absolutely certain, then that gives us a spectrum of chance. We can express that probability of something happening either as there's no chance, it's impossible, or it's absolutely certain. So an example of something that has got no chance of happening today would be to say at 12 o'clock the sun is going to set. We know that that's not possible. It's not going to suddenly get dark and the sun's going to speed up and happen. There's no possibility of that happening. It's impossible. But we do know that tomorrow morning, sometime between 6 o'clock and 7 o'clock, the sun will rise in the east. That is a certainty. We can stake everything that we own, and we understand that that's what will happen. There is a certainty that that's what will happen. We know that today is a particular day. Tomorrow will happen what will follow on. So if today is Thursday, tomorrow will be Friday. If today is Friday, tomorrow will be Saturday. And so there's a certainty about certain things. We can be sure of certain things. Now, we can't say that we're going to be alive tomorrow. It's a good chance that we'll be alive tomorrow, but we're not absolutely certain. There's some things that we're not certain about. We hope that we'll be alive tomorrow, but we're not definitely sure. Who knows? We could get run over by a bus, we could have a heart attack, anything could happen. But so we're not absolutely certain. There's some things that we're certain of, some things that we're not. But if we were to say somewhere in between those, what can we predict? There's some things that we can say there's a better than certain chance that something's going to happen. So some things we will say there's a chance. There's a 50% chance, or they're equally likely. So equally likely. Somewhere in the middle, we could say something like that we're going to find that the robots are working. There's a good chance that the robots are working, but then there's an equal chance that the robots might not be working. I don't know, maybe it's more than 50%. Most robots seem to be more than 50%. But let's take a simple example. If we take a look at tossing a coin, spinning a coin, heads and tails, you've got two outcomes. You can either have a head or you can have a tail. Either one. Having a child, you could either have a boy or a girl. 50% chance. It's equally likely. So robots perhaps might be there, or depends which part of the world might be there, but some things are equally likely. If we were to represent this scale in numbers, we could represent this no chance as 0 and as 1. We could also represent it as a fraction. In the middle over here, we could say there's a 1 in 2 chance. So it's equally likely. If we're saying something is less than that, we could represent it as a decimal, something like 0,2. If something is more than 1 in 2 chance, we could represent it as 0,8. Now, those are decimals. Fractions are normal fractions, 1/2 or 3 out of 8 chances of something happening. We could represent it as a decimal. We could also represent it as a percentage. And so an 80% chance that there's rain tells us that out of 10 days with the similar weather conditions, 10 days, on 8 of those days we'll get rain. 2 days, same weather conditions, same pressure systems, no rain. That means that we understand what weather predictions are. So getting learners to understand this big concept and seeing how to represent it is very important. But for learners to really engage with this content, and we talk about the teaching approach, we don't just want learners to learn this theoretically. I believe that this section provides an opportunity to do some real experiments, to do some testing within a classroom. And so we are going to be looking at things like games, and you can look at spinning a coin. Spinning a coin, we recognize if we take a few samples, we can take, say, 10 spins, and we can tabulate the results. We can then work out how many heads, out of the 10 spins, we ask the questions, how many heads out of the total 10, and how many tails. Now, if we got learners to do this in groups, we could have 2 learners spinning a coin, and they could do their 10, and they could come up with a set of results. We could then ask around the class, get learners into pairs. We could then get those results collated, and you would get 10 times the number of pairs, and have a look at, by increasing the number of spins, what it does to the probability, what it does to the chance. You might find in a particular situation, one learner, out of chance, just purely by chance, they might say, well, we managed to, without trying to cheat the system, get 8 out of 10, and we only got 2 out of 10. But if you increased it to a much bigger number, like, for example, 10,000 or 1,000 even, you would find that if you had a sample of 1,000, you would probably find it would be close to 500, which tells you that you've got a 50% chance of getting a head or a tail. It's 1 in 2. Over a bigger sample, you're going to get that narrowing down to what we expect it to be. Now, that would be one approach, dealing with games. Of course, you could deal with dice as well, and dice are really interesting. We could use 1 dice. And remember, what we've got here in 1 dice is 6 possible outcomes. Because we can roll a 1 all the way through to a 6. So to get a particular number, so to roll a 1, you're going to have a 1 in 6 chance. And so we can start to ask learners some questions about what the chances are out of the total possible outcomes. The total possible outcomes being 6, what will their favorable outcome be? And so we can begin to understand the expressions of probability. The interesting idea that I've seen done, and it's really interesting, is to take 2 dice and again do this practically. Get learners to complete the exercise with 2 dice. And what we will look at is the sum of the dice. You could even get them to draw up a table where they say on 1 dice, if that was 1, that was 2, that was 3, that was 4, that was 5, and that was 6, then 1, 2, 3, 4, 5, and 6. Get them to complete what the possible outcomes are and what the favorable outcomes will be, what the best score would be. And so you could then, having looked at a table like this, you could then begin to extract solutions to questions like, what's the chance of me getting a score above 5? What's the chance of me getting a score below 2? What's the chance of getting a score above 12? Well, let's think about that. It's an important question because we recognize that the maximum score is 6 on 1 dice and 6 on the other. So the maximum score is 6 plus 6, which is 12. So the chances of getting a score above 12 are absolutely 0. And we need to expose learners to the idea that some things are impossible. To get a score of 13 for 2 dice is impossible. And they need to understand that the probability therefore is 0. Now, these practical ideas of using, bringing dice, bringing weather charts, bringing things into the classroom, coins for them to spin, and asking them to interpret, this will make this type of activity for mathematical literacy on the section of probability really engaging. So learners begin to understand that this is something that they can really do. They recognize what the total possible outcomes are, and they're representing the chance of a particular selected outcome as a fraction. Of course, when we deal with grade 11s and 12s, another way of representing it other than tables is to draw tree diagrams. And so I would recommend that you show your learners that when we're dealing with different outcomes, so if we're dealing with choices, what are the possible outcomes? With that story of 2 dice, if the first dice lands on a 1, what can the second dice do? Well, it can either be a 1 or a 2 or a 3 or a 4 or a 5 or a 6. And so one can draw tree diagrams for a whole number of outcomes and begin to see what the possibilities are. So if you only had 1 on the first one, you've got 6 possible outcomes on the second. And so it would give you a 6 out of however many there are in the total of drawing 2 dice, which I think is 36. 6 out of 36, we go down to a fraction. You'll see that's again 1/6 of the possibilities. So tree diagrams are are important. They often come up in formal assessments, and I believe right from the beginning it's important that learners become familiar with representing what they're doing in a particular way. Okay, so having looked at a teaching approach and recognizing that this section really lends itself to practical activities, where classrooms can be turned into experimental laboratories, where learners can be doing a whole lot of things and collecting data and interpreting that data. I think it makes a lot of sense to say, well, how are we going to assess this process? Well, we're going to look at assessment strategies straight after this break. So don't go away. We'll be right back. Welcome back, colleagues. We're talking about, this is a Learn Extra Teacher Talk, and we're talking about mathematical literacy today. In particular, we're focusing on the teaching of probability. Now, when we come to this section, shown earlier, what the section requires: a discussion with learners about issues, a discussion with learners about the idea of chance, the idea of probability. What does it mean? And now we're going to change our focus of attention to talk about the assessment of probability. Now, the first thing that I want to mention here is that if we look at the CAPS document, when we talk about formal assessment, and even for grade 11 and 12 at the moment, we need to recognize that that probability is actually only a small percentage. It's a minimum in the CAPS document, a minimum of 5% of the total. And that means that it's restricted to paper 2. And so it's going to carry quite a small number of marks. Perhaps the intention of that was to say, well, look, this is a more challenging section, although I don't think it should be something that learners should be afraid of. If they get enough practice and they do these type of things, it's not high-level probability at all. There's nothing much to be scared of. What they need to recognize is apply some basic principles and recognize those principles in solving the exam problems. So even at a mid-year exam, for a mid-year exam, we recognize that it's only going to be about 15% of paper 2. That's according to the CAPS document. So it's not a whole lot of work, but it's so interesting and it's really important that learners grasp it. Now, as I mentioned earlier, it is such a hands-on section, and it's a pity to take that hands-on approach away from learners. And so I really believe that one of the other aspects, apart from the formal assessment, where it's perhaps scaled down, but the teaching of probability lends itself to investigations and assignments. And so even in the CAPS document, there are a couple of investigations and assignments that are included. And I just want to go over the first couple, just so that we've got a sense of what they are. The first one, which we're going to deal with, is the grade 10, which talks about unfair play. The other way of saying this is loaded dice. And so what we're recognizing is that normally we would expect when we flip a coin or roll a dice that there is a chance that is well known of what a particular score would be. So if we're dealing coins, we could even say loaded coin, then we recognize, we expect a 50% chance of getting a head or a tail. It's even. It depends on how many times you roll it, you will get that 50% score. Now, if we change the weighting, if we change the perimeters or the values of the coin, and make one want to lean in a particular way, then it becomes an unfair advantage. Now, when we deal with people that do games of chance on the street, they have ways of cheating the odds. And I'm sure one can talk about the games of chance that one sees. And so the one that comes out is that if you have 3 beakers and you cups, and you put a little thing underneath, a bead under one, and you shuffle them around, which one is going to be the one with the bead in it? And so people on the streets shuffle them around, and they get people to put money down, to bet, because they recognize you've got a 1 in 3 chance. Problem is that the vendor makes it easy to start, or the gambler, the con artist makes it easy to start. First of all, so you can see exactly where the coin is or the little bead is. Then they pick up the bead and they transfer it in the process, and so the person eventually gets to a case where they're putting a lot of money down and they don't get the right thing and they lose all their money. Now, that's an unfair game, and I'm sure that learners are aware of that. We need to talk to them about the fact that gambling can be unfair and that there can be loaded dice. And even if we talk about gambling that is straightforward and it is fair, so for example, going to a casino and using a fruit machine, particularly for grade 12s who might be tempted after they've turned 18 to go and play on these casinos around us, to earn some money, to get a greater chance. Recognize that there is a small chance. The probability is very small. There's a small chance of winning. Even if we took a look at the lottery, we need to discuss with learners and make sure that they understand that the chances of selecting the numbers that are for the national lottery are going to be a very, very small chance that you're ever going to win. We can discuss these as part of an assignment, and we'll come on to that. So understand that games of chance are sometimes loaded. If we take a look at casinos, the casino owners will always win more times than the gamblers will win. We need to make that clear to learners, and don't think that because you've won once, you're going to carry on winning. That's not going to be true. We have these superstitions that surround gambling, and we need to discuss these and make sure that learners understand that as you begin a game, your probability starts from 0 again. It's a new game. There's no sense of, well, it's a lucky number or something like that. The chance of getting a particular score is always going to be the same. Now, in terms of the unfair play assignment that is suggested in the CAPS document, what is suggested is that learners make or design a game that is unfair. They could use coins, or they could use dice. One of the things that has been investigated is that certain coins have different weightings. So if it lands on the center, so in other words, instead of spinning it and flicking it up in the air, if you hold it and you spin it on a flat surface, so it spins vertically, the chances of it falling one way or the other isn't exactly 50%. The heavier side will tend to fall face down. So one could spin a coin in a particular way to make it unfair. You could even add a little bit of weight onto one side of a coin, make a disc, and then spin it, not flicking it up and down, but spinning it on its side, and in so way make an unfair design. Getting somebody else then to test it and to seeing if it is it still 50%? Is there still a 50% chance? Is it a 50% chance? Obviously, that depends on the number of spins. And so one can collect data and get some information about that. Now, in grade 11, although this is for the CAPS document, I don't think it's beyond the current NCS to refer to the CAPS document investigations that are given for grade 11 and 12. And I would suggest that it's not a bad thing to let your learners have a look at this sort of investigation. There is a requirement to have the investigation, and the particular ones for grade 11 deal with grade 11 deals with a coin toss, tossing a coin, flipping a coin, and looking at the number of coin that you have to get, number of tosses. It also looks at the idea of pregnancy, or I would suggest even HIV tests. The idea of looking at false positive. What is a false positive? Well, it means that you get an outcome that's saying that it is a positive result when it's not true. And within all medical tests, with all statistical tests, there are the possibility of false positives. There are also the possibility of false negatives. We try, in terms of regulating tests from a medical side, scientists try to keep that percentage error very small. So it might be something like only 3% or less than 1%, 1.5%. Small numbers that are possibly going to give you a false positive or a false negative. And we need to understand from doing a statistical investigation and analysis that that will affect, depends on the sample size, a large number of people. That's why often people are required to duplicate tests, to do a second test. With a pregnancy test, you might do a home pregnancy test, and then the woman needs to go and visit a doctor to confirm it, either with a blood test or with an examination that confirms that pregnancy is true. False positives do happen. False negatives also do happen. With the HIV test, we need to recognize that within this parameter, that sometimes there are false positives and false negatives, and so a repeat test is usually required. When we talk about the grade 12 investigations, the ideas of gambling come up and ideas of risk in terms of car insurance. Getting learners to investigate what are the risk factors, what are the different rates, and who's at high risk and who's at low risk. This is a topic for grade 12 and not for grade 11. So getting learners to construct and do an investigation in class time as well as in their own time is an ideal opportunity to allow for some assessment strategies. And so I would really recommend to you that you use this opportunity also to get learners to communicate. Communication of information, of numerical information. And so the idea of giving them some presentations to do, and those could be oral, or they could be a poster. This might take a little bit of time from learners to put together, but it really is invaluable as they will get the opportunity to report back on their investigation. And I believe that that really does go a long way to meeting some of the objectives of making sure that learners can communicate effectively about numbers, particularly numbers that are related to mathematical literacy. The other idea is to look in terms of an assignment that is possible for grade 11s and 12s, is to look at probability in advertising. This links very well to data handling. and the section of data handling and probability are intermarried and interconnected. So, for example, in advertising, you might find that a claim from a cosmetics or a shampoo company will say 3 out of 4 women prefer this particular hair product. Now, one of the things that if they say 3 out of 4, that's equivalent to 75% of women prefer that product. One could always test to verify that claim. Now, obviously, this needs to have been done, if it's been done properly, on a large sample. But we could ask our learners to do it on a small sample and recognize that using a small sample, you might very well come out with a different value, a different number, which gives a different probability that is expressed as a percentage. So here, these are practical hands-on activities that learners can engage with. So they can look in the media, they can do a range of activities that make probability not a mystery, not something that has strange notation that you would find in maths textbooks, but rather here we're looking at very simple, very practical ideas around probabilities. Of course, the learners do need to make sure that they prepare adequately for the formal exams as well. And so practice in the typical types of examples, as we've mentioned, tree diagrams and the calculation using multiple events are important to look at as well. Now, what resources are available for the teaching of mathematical literacy? You could obviously go and have a look at the YouTube page, and you will find that there are some examples of where probability and statistics videos have been shown in our Learn Extra series, where we've dealt with probability as examples to show your learners. But there are a couple of others that I want to just particularly look at. And the first one is a video that is downloadable from the Mindset website, which deals with probability and games. And this particular video deals with the games of chance. And so what are the chances is what it's called, and it looks at games of chance. It looks at dice games and card games. It deals with a little bit about the lottery as well, and it starts to engage learners with the idea of gambling. I would really recommend that you use this video as an introduction to get learners to discuss the ideas of chance and the ideas of games of chance, recognizing that sometimes we can't predict what the outcome is going to be, but that we can get an idea of the outcome by looking at different possibilities, different games. What are the chances of rolling 9 with 2 dice? Doing those sort of calculations. The video goes through many of these examples. Now, if you're showing these videos in a classroom, what are the ways to do that? Well, obviously, one of the key things that I would suggest you do, if we look at the resources, the first one that I'm going to mention is what are the chances? The key thing that you need to do is, first of all, you need to review the video. Having reviewed the video, you will notice that there are different points within the video, different places within the video where you could raise a discussion with your learners. So look out for those places to pause the video. So you don't just want to show the video and let it run for the whole time. You would like to be able to show the learners the activity, look out for places to pause, and get them to engage. Engage in a question or an activity, and they could even ask a question. You could be involved in answering a question. Get them to ask questions as well. Video is fairly passive, and so it is important that you play a mediating role in that process. Make sure that the learners are concentrating and that they are engaged and watching, and you'll find that the storyline helps them through this particular video. Now, there is a second resource that I want to show you, and this one is perhaps a more serious one. And it deals with that discussion about the dangers and the issues relating to HIV and AIDS. This particular video promotes the idea of voluntary counseling and testing. So voluntary counseling and testing, VCT. I would really encourage you to open this discussion to your learners. This particular video, which I'm going to just show you a short clip, deals with the mechanism for the transmission of HIV and AIDS. And so it takes a random sample and does an experiment in class. I want to just particularly show you using probability here. What this particular teacher set up was a science type experiment where she had a whole lot of beakers and they gave out to learners behavior notes to say how they were to behave. So there were beakers with fluid in them, and they said, what you must do, this beaker represents an activity. Whether you must share and exchange fluid or whether you must never change fluid. And so there was within the sample of beakers just one that had a particular chemical in it. And as the learners went through the process, it then becomes clear about how they should interact and how they shouldn't interact. Having done the interaction or the engagement, they could then work out at the end how people, by just mixing the beakers were a model for activity, sexual activity, and their behavior was indicative about what they should do. And so you will see activity within the video as the learners went around the classroom, either exchanging, mixing the fluid in the beakers or not mixing. And so it comes out with a very interesting conclusion that relates to how HIV, the virus, is transmitted. And this is a practical discussion that I believe is of real significance for learners to be involved with. At the end of the day, begins to recognize that the chances of just casually interacting and not being contaminated, even with one sample, becomes very, very small. And so the chances of risk are highlighted in this particular video. And so it's a very important life lesson. And it might be important to link this to life orientation or life sciences, so that learners are more aware of the probability and the risk that they undergo if they engage in risky behavior. The video is really powerful, and we've had a lot of feedback from teachers who've used that particular video effectively within a classroom to say how their learners have benefited from it and how it makes probability and the idea of risk a really hands-on, concrete thing that they begin to understand so that they can make lifestyle choices that will affect the rest of their lives. Okay, well, I hope that you have got a good sense that there are indeed many ways of teaching probability, that this is not a section that one should shy away from, but that is something that is relevant, that's useful for learners, and something that is quite exciting as well. So from me, John, great to have been with you. I Hope you endeavor and push through in the teaching of probability and make sure that your learners achieve all they can in the learning of mathematical literacy. Thanks for being with me. Bye for now.